Hi everyone. Today I'm going to show you how to run the Python-based tool SeqLengthPlot to analyze the distribution of sequences in FASTA files. The tool allows you to visualize the length distribution of sequences in both linear and log scales and retrieve the resulting FASTA files based on the given length cutoff. First, visit the SeqLengthPlot repository on GitHub and follow our installation guide to install the required dependencies. This tutorial will cover installation on macOS. Although Python typically comes pre-installed on macOS, we will demonstrate how to install it via the terminal using Brew. Verify if Brew is installed. If not, simply copy and paste the provided command. Then export it using the subsequent command to make it available for the system. Then, install the latest version of Python from the terminal using Brew. Noteworthy is that incompatibilities have been detected between the latest Python version and Biopython libraries during installation. However, we will just show you how to install the dependencies, matplotlib and Biopython. Once the dependencies are installed, we can proceed to download the SeqLengthPlot script and files or clone the repository. You can follow the README file at any time to easily copy and paste the commands for installation and execution. Once the repository has been cloned, navigate into the cloned repository. Check the files and decompress assembly ss_se.trinity.fasta.zip to test the script. This file is original data derived from the single-end transcriptome of the false coral Savalia savaglia, cnidaria. Ensure you are using the correct Python version. Note: there are some mandatory parameters. Let's perform some tests and intentionally generate errors to understand the messages, fix the parameters, and overcome troubleshooting issues. For example, the I flag before the input FASTA is mandatory. For macOS, specify the backend as macOS X since the default is TAG for Linux and Windows. You can also type Python SeqLengthPlot v2.2.pih to view the command line options. These include specifying the length threshold, selecting the appropriate backend for your operating system, displaying the plot, analyzing nucleotide or amino acid FASTA files, and exporting the plot legend accordingly. By default, the tool is set to analyze nucleotide files with a threshold of 200 nucleotides, the standard cutoff length used by researcher when employing RNA-seq assemblers such as Trinity. By specifying the correct backend for macOS, warnings will no longer appear and the generated files will be saved in the working directory. By using the showPlot flag, you can view the generated plots in a pop-up window. In this case, the default length of 200 nucleotides or base pairs as nucleotides is used, as mentioned earlier. By default, all files will be saved in the working directory. 2 files containing sequences of both sides at the selected length of the splitting point, the corresponding plots in linear and log scale, and the statistics, number of input sequences, number of sequences in the split FASTA files, minimum and maximum length in each file. Now let's display an example using FASTA files containing amino acid sequences. This approach can be particularly useful for analyzing outputs from transdecoder, as well as for peptidomics or biodiscovery studies, such as bioactive peptide discovery involving length-based pre-filtering before applying machine learning and deep learning algorithms. In this case, we can apply a similar syntax to that used for nucleotide FASTA files. For instance, let's analyze the length distribution above and below 40 amino acids in the file detox output SSSE candidate toxins.fasta. This file is obtained from the detox pipeline after processing the single-end transcriptomic as that used for nucleotide files. However, we need to specify that we are analyzing amino acid sequences by using the -prot flag and set the desired cutoff. Let's now select the length cutoff to 40. When the prot flag is applied, the plots will automatically include AA in their legends, indicating amino acids instead of the default label for nucleotides. We hope you found this tutorial useful in making the use of this tool easier for your needs. Thank you.